Okay, we're recording. So we are doing module 12, malware forensics. So our module objectives: understanding malware and common techniques attackers use to spread it, understanding malware forensics fundamentals and the types of malware analysis that are out there, overview of static analysis, overview, apparently I can't say overview today, overview of analysis of suspicious Word documents, understanding dynamic malware analysis, analysis of malware behavior on system properties in real time, and understanding analysis of malware behavior in a network in real time. So they busted that out into 7 sections because malware has all sorts of different things. And number 1, sorry, helps if I go over that. Number 1 is malware, its components, and distribution methods. Malware is malicious software that damages or disables computer systems and gives limited or full control of the system to the malware creator for the purpose of theft or fraud. It, of course, has tons of different things listed under malware. Technically, viruses, worms, Trojans, adware, all of that is under the malware umbrella. So they have 7 different ways broken out that malware can get into a system: instant messenger applications and IRC chats, removable devices, links and attachments in emails, file sharing, fake programs and freeware software, browser and software bugs, and of course, downloading files, games, and screensavers from untrusted sites. Okay, so components of malware. Components of malicious software rely on the requirements of the malware author, who designs it for a specific target to perform intended tasks. So we have our malware component on the left and then description on the right. We have a ton of these. This is a nice one for us if you want to save it for later. We've gone over some of these before. We have what's called a cryptor, downloader, dropper, exploit, injector, obfuscator, packet, payload, malicious code, and fileless malware. Do you guys feel you need me to go through every single one of those one at a time, or do you feel that we've gone over these types before enough that you can understand it? Okay. Yeah, I was going to say, I got a whole bunch of, nope, you got it. Go over it for Steve. Very funny. But yeah, this is a good one if you're wanting to have a good slide for like basic components. This would be a good one for you to snip and keep.
German, you sure you're not having an issue with that slide? I mean, it's not written in crayon. Might be a little hard to understand.
Ooh, can definitely tell it's Monday. Common techniques attackers use to distribute malware across the web. We have black hat search engine optimization, malvertising, compromise legitimate websites, domain shadowing, social engineering, clickjacking, spear phishing sites, drive-by downloads, and mouse hovering. So ranking malware attacked pages in search engine page results on that top one, embedding malware in ad networks that display across hundreds of legitimate high traffic sites, hosting embedded malware sites that spread unsuspecting visitors, stealing domain account credentials via phishing to create multiple subdomains that direct traffic to landing pages hosting an exploit kit, tricking users to clicking on innocent looking web pages. Now that is like a bread and butter technique for a lot of these. Mimicking legitimate institutions in an attempt to steal login credentials, virus exploiting flaws in a browser, software to install malware just by visiting a web page, malware getting auto-executed when the user hovers their mouse pointer over any hyperlinked text or picture. They use like malicious PowerPoint slides shows. That's why you don't want to download anything like that. That's random. And then just go to click everything open and say, yeah, sure, go ahead and open all the attachments. 2, understanding malware forensic fundamentals and recognizing types of malware analysis. Okay, malware forensics introduction. Often attackers use malware like virus, worms, trojans, spyware, and ransomware to commit a crime on the intended target system. Malware forensics deals with identifying and containing malicious code and examining its behavior in a controlled environment. Performing malware analysis enables investigators to know the type of malware, how it works, its behavior, and its impact on the target system. You can use a set of tools and techniques to conduct static analysis, and then you have what's also called dynamic or runtime analysis for the malicious code. So why do you analyze malware? Determine exactly what happened, to determine the malicious intent of the malware. So a lot of times with malware, they'll have like processes within processes. So you may not actually be able to see exactly what's going on until you get down in and see, oh, they've got like 3 different subtasks going on here. To find out indicators of compromise or IOCs, determine the complexity of the level of an intrusion, identify the exploited vulnerability, identify the extent of damage from an intrusion, catch the perpetrator accountable for installing the malware, find signatures for host and network-based intrusion detection systems. Now on 7, sometimes malware programmers get cocky, or they have specific tricks to their programming that are like signatures, and they can create kind of like a psychological profile only with programming techniques. So they can go, okay, we've seen this. We think we know this is from whoever. They'll probably give them a specific like name and be like, this is this person. We just haven't attributed all of this to who it goes to. But, you know, people have certain behaviors, and so does the way that they write code. So what are the challenges for malware analysis? Accuracy of the process, detection of malware pieces and traits, the amount of data to be analyzed. That one's a big one. The changing technologies and dynamics of malware creation and propagation. If you just think back to even last year and the vast change that we've had over year from year in malware attacks and ransomware attacks, and it changes so quickly. Sorry, go ahead.
I was just going to say, I'm wondering how long it'll be before I can get some version of ChatGPT to write me a malware script.
You know, I would not be surprised if someone doesn't have a version of that they're already working on, because it would make, I was going to say you can do that now. Nick's already on that, but yeah, I can believe it. Because AI is a tool. How you use it depends on the person. Anti-analysis procedures like encryption, code obfuscation, and then, you know, deleting the records are also a problem. Identifying and extracting malware. So if a user's reported suspicious activity on their system, you have to examine the following areas of the system to find traces of the malware installation. So what are we looking for? Installed programs, suspicious executables, auto starting locations. That's a really good one because a lot of people don't pay attention to those auto starting locations, so they have no idea what a normal auto start program is. Scheduled jobs, same kind of thing. Services, modules, logs, user account and login activities, file systems, registry entries. There's usually a bunch in there, even if they're partial entries that can point you towards something. Traces from applications and restore points. You can use tools like Ballbuzzard and Cryptam malware document detection suite to extract patterns from malicious files for investigation. You can perform static and dynamic analysis together to identify the intent and capabilities of the malware. Prominence of setting up a controlled malware analysis lab. Usually malware analysis is carried out by infecting a system with malicious code and then evaluating its behavior using a set of monitoring tools. Therefore, you have to have a dedicated laboratory system that is required, and you can infect it while keeping your other stuff safe. Usually these are also not anywhere near your network. So the way that they have it listed here for best way to set up a lab, using a physical system isolated from production network to prevent the spread of malware. Yeah, you don't want to oops, click and go, oh, look, that's what it does, and infect everything. Virtual software is also a really good option, like VirtualBox, VMware, things like that. Because if you set up a physical system with multiple VMs running different OSs, that gives you more stuff to test. But just remember that physical system should not be attached to your production network. Importance of virtual environments for malware analysis. So this protects real systems and the network from being infected by the malware under analysis. It's easy to analyze malware interactions with other systems. It allows screen capturing during analysis, ability to take a snapshot of the laboratory system, which can be used to easily revert to a previous system state. Okay, so how do they prepare test beds for malware analysis? Well, you allocate a physical system for your analysis lab, install your virtual machine, install your guest OS, isolate the system from your network by ensuring that the NIC card is in host-only mode, or you can do the old-fashioned way and just unplug the cord. Simulate internet services using tools like iNetSim, disable shared folders and guest isolation. Install your malware analysis tools. Generate hash values of each OS and tool, and then copy the malware collected from the support machines onto forensic workstations. So here are some different malware analysis tools. So the top, it goes from different types here. We have sets for hypervisors, network and internet simulation tools, screen capture and recording tools. And those are really nice, especially if you want to just run it and be like, hey, here's a video of what this did. OS backup and imaging tools. And in a lot of the forensic classes that I've done, R drive image has been used. I haven't used the other ones, but that's not saying they're bad. It's just I haven't used them. So what are the general rules for malware analysis? During malware analysis, pay attention to the key features instead of looking at each and every detail. It's just kind of like when you look at an entire incident, there can be tons and tons of things going on, but that massive amount of detail might be trying to hide what the absolute most important features are. So that's what they're talking about. Try different tools and approaches to analyze the malware, as single approaches may not be helpful. A lot of times, one tool will not get you all of the information. So that's why you use multiple tools and approaches. Identify, understand, and then defeat new malware analysis prevention techniques, so that you know how to get around them getting around you finding stuff. But just be aware that that is a continual cycle, and just because you may fix it now, that means someone down the road is going to figure out how to do that then. Okay. So you know how we've talked about programming with static and malware, static and dynamic analysis? It's the same thing here. We have static and dynamic malware analysis. So static analysis, this is their code analysis, and it involves going through the executable binary code without actually executing it to hopefully better understand the malware and its purpose. Disassemblers like IDA Pro can be used to disassemble those binary files. And then dynamic malware analysis, or also called behavioral analysis, involves executing the malware code to know how it interacts with the host system and the network. This type of analysis requires your virtual machines and sandboxes to deter the actual spread. And then you also use debuggers which are used to see what's going on at the time of execution and study its behavior. Both techniques are intended to understand how it works, but differ in the tools used and the time and skills required for performing analysis. Both static and dynamic analysis are recommended to better understand the functionality of malware. It really depends on if you come from a programming background. If you come from a programming background, you're probably going to be really comfortable with doing a static analysis. If you come from a more application and network and background, you're going to need to see how it interacts with things. So you're probably more comfortable with a dynamic malware analysis, which is why a lot of times they have people that do a combination of both. Okay, next, static malware analysis. So, analyzing the binary code provides information such as data structures, function calls, call graphs, etc. Load the binary code on your test system, preferably the OS on which the malware is not designed to run. That's just to make it harder for it to to be able to reach out, to analyze its static properties. Some of the static properties of the binary code to be examined include strings embedded into the file, header details, hashes, embedded resources, packer signatures, metadata, etc. Some static malware analysis techniques. You can do file fingerprinting, online malware scanning, performing string searches, malware disassembly, identifying packing or obfuscation methods, finding the portable executable information, identifying file dependencies. So what is file fingerprinting? It's recommended to compute the hash value of a given binary code before carrying out this investigation. Common hash calculators. So remember HashCalc, the one that I showed you guys how to use? That's an example of one of them, but there's a bunch of them that you could use. Then you use the hash value to periodically verify if any changes made to the binary code during analysis. Online malware scanning. Scan the binary code using renowned and up-to-date antivirus software. If the code under analysis is a component of a well-known malware, it may have been already discovered and documented by many antivirus vendors. Go through their documentation to recognize the code capabilities, signatures, etc. You can also upload the code to websites like VirusTotal and get it scanned by different scan engines. So remember I took you out to VirusTotal and showed you how to check the hash files? Well, you can also do this on there. Yeah, VirusTotal is a pretty cool website. There's a lot of things you can do with it. String searches. Strings communicate information from the program to its user. Analyzing embedded strings of the readable text within the program's executable file, like status update strings or error strings, are what they're talking about. Use tools such as strings, resource extracts, bin text, hex workshop, etc., to extract embedded strings from executable files. Ensure that the tool extracted strings are represented in ASCII and Unicode formats. On extracting, you can see the input of strings of interest in search engines for more information. So as you can see, they have a tool over here and you can scan. It says, hey, we've got this thing checked for strings. And then you can see the dump out here below, some strings. And then I'm guessing the number is probably the line of the code that it's on. Now, why do you think you have to do ASCII and Unicode? Do you guys remember how they had different things that are hidden using different forms there? When we were talking about like cross-site scripting and different things like that. If you use one but not the other, sometimes you miss what the actual strings are in. Yep, you got it. Identifying, packing, and obfuscation methods. So attackers often use packers to compress, encrypt, or modify malware executable files. There are modules in a lot of those, a lot of the script kiddie programs that are super easy to do that with. It complicates the task of the reverse engineers in finding the actual program logic and other metadata via static analysis. If you use tools like PEID, which detects most common packers, cryptors, and compilers for PE executables, and you can see this one right here, and it looks like it gives you a bunch of different options that you can set in here. PE, or portable executable information. PE format is the executable file format used for Windows operating systems. Information available for examining the metadata of a PE file, time and date of compilation, functions imported and exported by the program, if there are any linked libraries and what they are, and then you have a whole bunch of icon menu, things like that that are embedded in resources. There are some tools like PE Studio and down there, which you can extract that information with. And the screenshot over here looks like it's PE Studio that you're using. Identifying file dependencies. So programs store the import and export functions in the kernel 32 DLL file. Examining the dynamically linked libraries or DLL files in the malware executable file. Finding all library functions may allow you to guess what the malware program can do. So if you figure out what it's targeting, then you can figure out possibly what it's trying to do. You can use tools such as Dependency Walker, which lists all dependent modules within the executable file. And you can see over here, they've got that one run. Malware disassembly. Disassemble the binary code and analyze the assembly code instructions. You can use tools like IDA Pro that can reverse machine code to assembly language. Based on the reconstruction assembly code, you can inspect the program logic and recognize its threat potential. This process is carried out by using debugging tools such as OllyDebug and WinDebug. It looks like we've got OllyDebug over here, and it shows them doing that there. Next, analyzing suspicious Word documents. Okay, so how do you find suspicious components? You analyze the suspect Office documents with OLED to detect any specific components that can be labeled as malicious or suspicious. To use OLED, open a new terminal on Linux. This one's got a 1.2, and there's your path. And then here the analysis has revealed that the Word document named infected doc contains VBA macros. Now, usually in Word, that's why in a lot of email programs, they have macros and things like that turned off so that it will actually detect these when they get emailed out, so you can't see them, but that doesn't mean people aren't going to find them some other way. So you can use this tool and it will scan these documents and go, hey, this is bad. Finding macro streams. Parse the suspect Office document with OLEDump to identify the streams that contain macros. This one's a Python command. In this Word document, stream 8 has been identified to store malicious macro codes. You can see they've got it circled down here. And I believe this is also a Ubuntu command prompt. Dumping macro streams. So you can extract the contents of any particular macro stream with OLEDump. There's the Python command. And then we have the screenshot that shows the macro code stored in stream 8. And then you can see the stuff dumped out there. Identifying suspicious VBA keywords. You can parse suspect documents with OLE VBA to view the source codes of all VBA macro and detect suspicious keywords and potential indicators of compromise. Then there's the command you can run there. And here the keywords and IOCs detected by OLE VBA show that the macros in the Word document have auto open functionality, contain shellcode and strings obfuscated with base 64 and DryDex, and they might download file names, test files named text.exe, and you can see a couple of them there. And then there's a web link and a text directory there too. On here, you can see those circled, and then on the top, and then you can see that down here on the bottom. Performing dynamic analysis. So this refers to the process of studying behavior of malware by running it in your monitored environment. Dynamic malware analysis makes it easy for investigators to observe in real time how malware interacts with system properties and the network. There are two approaches for dynamic malware. We have monitoring host integrity and then observing runtime behavior. So with host integrity, this involves taking snapshots of the system state using the same tools before and after analysis to detect any changes made to the entities residing in the system. And then runtime behavior involves live monitoring of the behavior of the chosen malware as it runs on your system. So here's your pre-execution preparation. Create a fresh baseline of forensic workstations. Take a snapshot of the registry keys, file system, running processes, and event log files. List all Windows services, device drivers, and startup programs. Install tools that will capture the changes performed by malware on the system resources, such as registry, file name, process, etc., as well as network properties. Generate hash values of the OSs and the tools, and then run the malware on that forensic workstation. So monitoring host integrity. Upon creating the baseline image, run the malware on the Windows Forensic Workstation for a certain time period. It says, note in this scenario, they will be executing a malware named payload.exe. Then take the second snapshot of the workstation and compare it with the baseline to detect all changes made in the file system and registries. Use tools like What Changed Portable that scans for modified files and registry entries and lists them in text file format. So you can see here, this one found 141 new registry entries in their What Changed snapshot. So runtime behavior, observing that, refers to the execution of malware on Forensic Workstation, observing its operations in real time to understand its intent and functionality. You can learn about behavioral characteristics of the malware by monitoring its attack activity on the system and network. Runtime behavior analysis of malware can be done in two ways: system behavior analysis and network behavior analysis. So system behavior analysis involves monitoring the changes on your OS resources upon the malware execution. System behavior analysis includes monitoring registry artifacts, monitoring processes, services and startup folders, event logs, examining event logs, monitoring API calls, device drivers, and then files and folders. So what does the network behavior analysis involve? Well, this one is tracking malware's network level activities. And what all does that include? Monitoring IP addresses, looking for connected ports, and examining DNS entries. Okay, perform your system behavioral analysis. So I have a nice little graph here. Malware manipulates the registry to ensure that it runs automatically whenever the computer boots or the user logs in. This is monitoring registry artifacts. By running the malware on a forensic workstation, you can observe its activity on the registry and look for specific keys or values that are read, created, modified, or deleted by it. Look for Windows Auto Start registry locations that are commonly targeted by malware to persist on the system. Okay, so we have our little flow through here. Monitor your registry artifacts, analyze auto start registry locations, and then you have our run keys, run once keys, and our startup keys that you need to check. So what are those keys? Well, here's a nice list of them. We have our run and run once keys, and then our startup keys. This is actually really nice to have them listed out. You can also Google this as well. Analyzing Windows Auto Start registry keys. You can use tools like Reg Ripper that comes with a GUI and command line tool and can parse keys, values, and data from the registry. Command to parse auto start registry key contents from the NT user DAT file of a specific user. You can see this listed here. We have the RIP.exe, which is our Reg Ripper, and then your location, and then you can see that it's outputting that into an output text file. And then on the right, here the extraction of data from auto start keys show that the malware has appended a persistent VB script file under the run key to run automatically on user login. You can see those circled here. A new name created, the top one there, under the run key. Then you have your malicious VB script file installed to achieve persistence. And then we have our script file path. So, monitoring processes. Some malware also uses portable executable to inject themselves into various processes like Explorer.exe or web browsers. Process monitoring after the execution of the malware on the forensic workstation helps identify the processes the malware initiates or takes over. Use process monitoring tools like Process Monitor to scan for suspicious processes created by the malware. And you can see that right here. It just shows your real-time file system. Monitoring Windows services. This tool can help trace malicious services initiated by the malware. It can create services without restarting Windows, deleting existing services, and changing service configurations. Sorry, I had a cat run across my keyboard. Malware spawns Windows services that allow attackers to remotely control the victim machine and pass malicious instructions. They may also employ rootkit techniques to manipulate that HKey local machine key right here to hide its process. And examining Windows services upon malware execution helps to identify any suspicious services created by the malware that might run automatically or require manual intervention to get started. So, remember how I talked about startup programs? Well, when we're doing analysis on this, malware can alter the system settings and add themselves to the startup menu to perform malicious activities whenever the system starts. And here are your steps to check hidden malware on that. You can check your program entries in the registry, check automatically loaded drivers, check your boot INI or BCD entries, check your startup Windows services, and then check your startup folder. Now, there are some alternate tools that you can use that will just straight up list everything that starts automatically as well. Auto runs for Windows, so like this, displays programs that are configured to run automatically during user login or system boot and help detect suspicious startup programs and processes. As you can see, they've got those circled out here. Monitoring Windows event logs. These are very handy, and you'll see this mentioned several times. Windows event logs are stored in, you see the path there, and they have the extension ETVX. Execute the malware on the Windows forensic workstation and monitor the events triggered by the execution and operations. Use the event viewer utility to monitor the events based on specific details like your event ID, event name, event description, etc., and then check and see if you have any malware indicators. API calls. So malicious programs often make use of Windows APIs to access OS information, such as file systems, threads, registry, and the kernel. API call monitoring helps understand malware's interaction with the OS and might provide valuable information regarding its system and network level activities. Use tools like API Monitor to intercept API calls made by the malware during runtime. You can see here they've got it listed out and everything. I like that this has like a nice flow menu that you can see how things are going through the API calls. Come on, next slide. There we go. On this one, they're just showing how using this API monitor tool reveals the following. On this one, the malware has repetitively used create file A and NT create file functions to create malicious files in system folders of the Windows Forensic Workstation. It's attempted to create a number of HTML and SCR files with those names right there. Although the Nemo, that makes me laugh. Yeah, someone else thought it was funny too. Device drivers. Yep, they can use weird device drivers too. Malware gets installed along with device drivers downloaded from untrusted sources and uses them to shield or avoid detection. You must scan for suspicious device drivers and verify if they are genuine and downloaded from the publisher's original site. So here is how you get into that. It's called Driver View. I've actually used this before. It's a pretty neat utility. It displays a list of all device drivers currently loaded on the system. For each driver in the list, additional information such as the load address of the driver, description, version, product name, and the company that created the driver is displayed. Yeah, malware it sucks. Malware in device drivers it's not as common, and when it's there, it feels like you're digging with a shovel by that point. Files and folders. You can use file and folder integrity monitoring tools to examine the file system and folder activity real time on an infected system. There is SIG verify, that's your signature. Checks the integrity of critical files that have been digitally signed by Microsoft. And this is, you go and start run and type in SIG verif and press enter. There is FCIB. This is a command line utility that computes MD5 and SHA hashes. And then there's Tripwire. And this one's an enterprise class system integrity verifier that scans and reports critical system files for changes. PA file site. This is a file monitoring utility that audits which user application is deleting files, moving files, or reading files. And it can generate reports with details that include user accounts, including domain and Active Directory, user computer name, target file and folder, activity done on the file, that read, write, delete, and then date and time of action. Okay, there's FastSum and WinMD5. So FastSum is used for checking integrity of the files. It computes checksums according to the MD5 checksum. And then WinMD5 is a Windows utility tool for computing MD5 hashes of the files And those are those fingerprints that you have to check to make sure your file is not corrupted. All right. And lastly, network behavior analysis. So, malware tries to communicate with the network for various activities like propagation, downloading malware content, transmitting sensitive files and information, offering remote control, and all sorts of other things. While inspecting the forensic workstation upon malware execution, you should check for the following aspects: IP addresses going from and connecting to the workstation, ports being opened on the workstation, and a list of DNS entries recorded on the workstation. 1 second. Cough hack, sorry. Okay, monitoring IP addresses, Wireshark, our favorite. So run that on your forensic workstation. Execute the file that's suspected to be malware on the workstation. Monitor the live network traffic to look for suspicious activity. Locate any remote IP address that the workstation is trying to communicate with. And then scan that IP address via online malware scanning tools. And then that'll help you find out if it's suspicious. Port monitoring. Malicious programs open system ports to establish a connection with remote systems, networks, or servers, and accomplish various malicious tasks. Reviewing port activity in real time on the forensic workstation after malware execution helps in understanding its network capabilities. For example, malware requesting port number 25 might indicate that it's trying to get connected to an email server. Use the command line tool like netstat. So I'm sure you guys, we probably remember we've talked about netstat quite a few times, to monitor all active ports and their status on the workstation. So there's also, for port monitoring TCP view. This one shows a detailed listing of all TCP and UDP endpoints on your system, including local and remote addresses and the state of TCP connections. You can see a list down on this one. And then there's cur ports, which is just, I'm assuming they were trying to shorten current ports. This is a network monitoring software that displays a list of all currently open TCP and UDP ports on your local computer. And you can see an example of that below. DNS monitoring. Malicious programs use domain name systems or DNS to communicate with their command and control servers. Upon malware execution, review the DNS records stored on the workstation to understand whether it's trying to call out a specific domain name. Note, before executing the malware, clear the existing DNS cache on the workstation by entering, that's the IP space slash flush DNS. That'll clear anything that you might have in there. And that way you can be sure that you're getting a current DNS reading. If you're not sure if you need to do this, remember our famous IP config space slash all, and that'll give you an idea of what's there. But you know, it never hurts to flush the DNS. DNS query sniffer. This is a network sniffer utility that shows DNS queries sent to your system or sent on your system. It helps in identifying DNS servers that malware tries to connect to and the type of those connections. So you can see over here, it gives you a nice big list, gives you the port number, the query ID, what type of request, and it gives you some other information. I'm guessing from the size of the bar on the bottom, it gives you a lot of other information. All right, you hung in there with me. Good job, guys. So what did we talk about in this module? Malware, 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 and the common techniques attackers use to spread it. We covered the fundamentals of malware forensics and the types of malware analysis. And we also talked about examination and analysis of Word documents and some other things like that. And then we talked about static and like real-time malware behavioral analysis as well. So I know it's Monday and asking you guys questions is probably going to be painful, but do you have any questions on this? Is there anything in particular you have a question on? Yeah, it was a lot. Sorry, I know it was a big one. Yep. Okay. All right. So I'm going to go ahead and stop the recording right here, and I'm going to talk to everybody about homework.